Okay, so moving towards the next lecture, as in the previous lecture we have derived the formula for the potential for the voltage divider rule. We have derived the basic formula in which we could easily find the voltage drop across the resistor directly. Okay, now so today we are going to solve an example. For example, you are given a circuit like this in which the voltage source is a 30 volt, the resistors are R1 equals to 3 ohm and R2 equals to 6 ohms, and the question is that the compute the voltage drop across the resistor. So as we have found it and we have derived the voltage divider rule in the previous lecture, so by putting the values simply in that, we will the voltage drop across the each resistor will be found directly. But before that, for knowing the importance of the voltage divider, we will do it by Ohm's law, so that we could know the advantage of the voltage divider rule. Okay, so before solving it directly by the voltage divider rule, for knowing the importance of the voltage divider rule, we will solve it as before we have found the voltage divider rule by the simple method. For that reason, we have to calculate the total resistance R, that is equals to R1 plus R2, 3 ohm plus 6 ohm, it becomes 9 ohm. After that, we have to find the current by the Ohm's law. V equals to IR or I equals to V by R, putting the values, and the answer comes to 3.33 ampere, the current that will flow in the given circuit. After that, we will find the voltage drop across R1. V1 equals to IR1, putting the values, and the answer comes 9.99 volts, and the voltage drop across R2, which is equal to V2 equals to IR2, putting the values, and the answer comes to be 19.98. So this we have found directly by another method. Now what if we found it by the voltage divider rule? Okay, so finding it on voltage divider rule. Okay, so as the total resistance is the same, that is that R equals to R1 plus R2, 3 ohm plus 6 ohm becomes 9 ohm. The general formula for the voltage divider rule is Vn equals to V divided by RT and Rn, where N represents the number of the resistor of which we have to find the voltage drop, and RT is the total resistance. Okay, so here now the voltage drop across R1, here N equals to 1, as we have to find the voltage drop across resistance 1, and RT becomes equals to R. The general formula becomes V1 equals to V divided by R, as R equals to R2 and into R1, because here N equals to 1. Putting the values, and the answer comes 9.99 volt. Looking back, the answer that we have derived before by the another method, that is the same here. Okay, now moving towards the second resistor. Okay, so now the voltage drop across the resistor, the second resistor, that is R2. Here N becomes equals to 2 and RT is equals to R. The general formula becomes V2 equals to V by R into R2, put in the values, 30 by 9 into 6, 3.33 multiplied by 6, and the answer comes 19.98, which is same as we have derived before by the another method. So basically the voltage divider rule saves the time, and through this we can find the voltage drop across any resistor in a circuit directly without calculating the current in that circuit. So in the previous method we have calculated the current first, and after that we have find the voltage drop across that resistor. But in this method, in the voltage divider rule, we have not defined the current. We just putting the values of the total resistance that would be given, and the total voltage, and across that resistor for which we have to find the voltage drop, and we will the voltage drop across that resistor will be calculated quite easily. Okay, so thank you for watching. Please subscribe.